Good afternoon, all my dear students. How are you all? I hope you are taking care of yourself as well as of your family. Today I brought the second part of the Unit 4 P block elements in front of you all. We have read the S block elements, the part 1 in Unit 4. The two groups come under S block elements, the group 1 and group 2. Now we move towards the P block elements. What is the learning outcome of this lecture? The students are able to understand about the P block elements in the periodic table, its general properties, the various compounds of these elements like oxides, hydrides, oxyacids, halides with their properties, as well as the diagonal relationship of the P block elements. So the following topics we cover in this lecture. We should go for the introduction of the P block elements, the general properties of the P block elements, the various compounds of the P block elements like oxides, hydrides, oxyacids, halides, and the diagonal relationship of these elements. So what are P block elements? The elements in which the last electron enters to the any one kind of the three p orbitals. We all know that is px, py and pz. Three orbitals are there in the p subshell. So if any of the element, its outermost electron enters to any one of the three orbitals, can be categorized as the P block elements. So it is on the right hand side of the periodic table. So the group 13, 14, 15, 16, 17 and 18 come in this category, excluding the helium. So that are considered as the P block elements. In these elements, the s orbital of the outermost shell is completed. And the electronic configuration we can have, the S subshell is completed, so NS2, NP1. It can reaches to NS2 because maximum 6 electrons can enter in the P orbital, so it can reaches to NP6. NS2 NP1 to NS2 NP6 is the electronic configuration of these elements. So these are called the P block elements, and 13, 14, 15, 16, 17 and 18 groups come in this category. Only you have to exclude helium. So let's move to the general properties of these elements. We go for general properties of these elements. So they are generally non-metals or the metalloids. Some heavy elements are also present in this block. We have like bismuth and lead. These are the heavy metals. So in this category we can say they have non-metals, metalloids, heavy metals. If we go for its physical state, they exist in all solid, liquid, gas, reactive, non-reactive, all type of elements are there, existence come under this P block. The third property we can say they have a definite valency, one valency we can say, but some elements like nitrogen and phosphorus have more than one valency. Like nitrogen exists in both 3 and 5. We have the ammonia and nitrogen pentoxide. So that can be have a variable valency elements in this category. So the next property of these elements, they form the complex anions like carbonates, nitrates, sulfates. So they usually combine with the other elements to form the anions. The next is the oxides are generally acidic, but some are, we are having the amphoteric. The well-known amphoteric oxide is aluminum oxides. So we can say the p block elements are having the acidic oxides. Some are amphoteric in nature. Except the ideal gases, these are called the normal elements. The S and P block elements are called normal elements. D block elements are called transition elements. And F block elements are called inner transition elements on the basis of the property. So they are considered to be a normal elements. Now we move towards the another property, that is atomic radii. If we see from the period 13 to the 17, except the noble gas group 18, because their radii of group 18 were not known yet. It's because they do not form compound, because they are inert. That's the main thing here. So the radii of a group 18 cannot be known to us. So we can say the atomic radii from 13 to 17 moving left to right in the period, that is, goes on decreasing. The ionization energy, it also increases moving left to right in the period, and if we talk about in the group, it decreases because it goes on reducing its reducing power of the p block elements. So that is the general property. The exceptions are there in the p block elements, like a high ionization energy of the noble gases because of the stable electronic configuration. You cannot have cannot able to release the electron, and the ionization energy of the noble gases is very high due to the stable electronic configuration, and the high ionization energy of group 15 because of half filled electronic configuration. On the basis of electronic configuration, if it is stable, it cannot easy to remove an electron from its gaseous atom, so its ionization energy is high. It requires higher energy to release the electron. So these are the exceptions on the basis of the electronic configuration in the p block elements. Now if we see the electron affinity, it increases on moving left to right. As we know, it goes for decrease in the size of the atom. And the halogens comes in the group 17, which has had the maximum electron affinity. But if we see down the group, the electron affinity decreases. But here again the exception come nitrogen and phosphorus, because due to the half filled electronic configuration, that is the stable configuration, we do not have the electron affinity goes on very high in this case. High. Electronegativity, if we talk about, it increases on moving again left to right, we know, and decreases due to the decrease in the size. It goes on decreasing down the group. So as we all know the trend of these property, it goes on. The next property, general property, we can have the polarizing power and the polarizability we have understood in the ionic solids. It increases from left to right. The polarizability and polarizing power increases because it depends on the charge. Charge goes on increasing from left to right. That's why the polarizability increases. The polarizability of the anion increases on moving down the group as the size increases. As you know, the cationic size should be small. Its polarizing power is very high. So for the cations, if we see from left to right, the cationic charge increases, polarizing power increases. As we move down the group, the anion capability goes on increasing because the size goes on increasing. So size of anion is responsible for the polarizability. We have understood in the ionic solid this concept. Now we move towards the compounds of p block elements. Which kind of compounds generally it goes on existing? The first we talk about its oxides. The p block elements form all the type of oxide, and most of we have discussed that they are acidic, they are amphoteric, but some basic, some few from the metallic elements. If they are metals, they form the basic oxides, but mostly they produce acidic generally and amphoteric oxide, which formed by the metalloids, acidic by the non-metals, and specifically the metals form in that the basic oxides. Non-metals generally form the oxyacids also. The oxyacids, we can have the nitric acid, sulfuric acid. So if we talk about the acidic character in a group, if we talk the acidic character of the oxides, it goes on decreasing down the group. And if we move left to right in the period, the acidic character of the oxides goes on increasing. Here I have taken an example of the group 14, the CO2. It is very highly acidic in nature. Then the second element oxide here, that is silicon oxide, which is less acidic than CO2. And if we talk about germanium oxide, it is slightly acidic and slightly basic, that is amphoteric in nature. Now here tin oxide and lead oxide, its basic character goes on increasing. So acidic character decreases here. And if we talk about in a period, here aluminium oxide, that is amphoteric, but silicon oxide, it is acidic, but it is less acidic than CO2. Then if we talk about phosphorus oxide, it is fairly acidic. Sulfur oxide is more acidic, SO2, which forms sulfuric acid. And then we have the chloroxide here, most acidic. So in the period, the acidic character goes on increasing, and down the group it decreases. So the next compound we talk about the hydrides, the reaction with the hydrogen. So hydrides of the non-metals, such like the oxygen when combined with the hydrogen to form water and HCl, they are highly stable hydride. They go for having the existence. So the stability of the hydride we can understand down the group, it goes on decreasing down the group. Okay, when we talk about down the group, it decreases, and the acidic strength increases in the same order as it goes on increasing, increases, decreasing, decreases. So the hydrogen iodide among all the hydrides form the strongest acid in the water. Here I have taken the example of group 15 here, the nitrogen hydride, that is ammonia. It is very stable. Then we have a phosphorus, arsenic, then we have antimony and bismuth. So the third compound we talk about here, that is the oxyacids. What are oxyacids? When the oxide combined with the water, it forms the oxyacids. So many of the P block elements form the oxyacids, and the strength of the oxyacids goes on decreasing down the group. Okay, so and we talk about the period, it increases the left to right in the period. So here you are saying the sulfur, nitrogen, sulfur oxide, nitrogen oxide combine with the water to produce oxy acids. So the P block elements form the oxy acids. That's the third compound. We have talked about the oxides, then we have talked about hydrides and then oxy acids. Now we move towards the halides. With the halogens, non-metals form the covalent halides. Generally, they have the covalent character. When we move towards left to right, the ionic character of the halides decreases and the covalent character increases. Understood? Because of what? We have seen the property, polarizing power of the cation in a period goes on increasing. That's why, because the charge goes on, we have an increase in the charge, that is cause charge of the cation increases the polarizing power of the cation and the covalent character of the halides increases. As we talk about this aluminum, I have taken the example of the halide aluminum fluoride. This is ionic in nature, and then we talk about aluminum chloride, that is in the middle of the ionic and the covalent, and then we move towards the aluminum bromide and iodide. So due to the atomic size of the iodide, which is bigger than the chlorine and the fluorine, that is anion. So the size is bigger, its polarizability increases, and the polarizability increases means the covalent character increases. Now the next we can see many of the similarities we have in the boron and aluminium. In the p block elements, boron and aluminium is having more similar properties because of the electronic configuration. As you are able to see the electronic configuration of boron, 1s2, 2s2, 2p1, and in aluminium also it comes the same, 3s2, 3p1, due to the same as having the s block and one last electron in the p subshell. Due to this, the various similarities found in boron and aluminium. And it is go for having the oxidation state also very similar. The oxidation state is a tendency to lose the electron, and the boron and aluminum have the tendency to lose the 3 electron, and its oxidation state is +3 of both. This is the similarity found in the oxidation state, similarity in the electronic configuration. Then we have the similarity in the covalent character also, because they formed the halides like boron trichloride and the aluminium trichloride of the valency 3 of both, they form having the valency 3 halides. So these are the similar characteristics found in the boron and the aluminium in the p block elements. Now we talk about the diagonal relationship. As we have discussed the diagonal relationship, when we move towards in the period diagonally, we found the net increase and decrease properties cancel out each other, forming the relationship to one another. So let's see the diagonal relationship in the p block elements. The first diagonal relationship we have of boron and the silicon. So diagonally, as we move left to right, the boron is in the 13 group and having the relation with the second element diagonally of the group 14, that is silicon. Silicon is the second element of the 14 group and boron is the first element in 13 group. So this is the diagonal relationship found in both. How we can understand this diagonal relationship? Because of the these properties, similar properties we have, like a non-metallic character. Both are non-metals. This is one of the character having the similarity, having the high melting points and the bad conductor of the electricity. If we talk about its non-metallic character, melting point and the conduction of the electricity, this is same. Then the next property is allotropy. Both the elements show the allotropic forms. So that is again the similarity. The third similarity is oxides. So it goes for forming the oxide which is highly stable and acidic in nature. Both oxides are acidic in nature. This similarity is there and both are stable. So this is the common property again found in the boron and silicon. As we have seen the reaction, it is acidic in nature. It reacts with the base NaOH to form the salt sodium borate here, and here SiO2 also react with the NaOH to form sodium silicate. So here the similarity is found having the acidic in nature and they are both oxides are stable. The hydrides, if we see, so hydrides also covalent hydrides, they both form like B2H6 and Si2H6. So they having the covalent hydrides. They both are semiconductors. They are having the partial conduction of the electricity, semiconductors. If we talk about its chemical property, action with the alkali, both dissolves in the alkali to form borates and silicates. Here you have seen before also their oxides are forming borates and silicates, and similarly the elements itself form the sodium borate when react with the alkali. So they easily goes on dissolving in the alkali to form these borates and silicates with the liberation of the hydrogen gas. So they both having the same reaction and same action with the alkalis. Now the second diagonal relationship in the p block elements is carbon and phosphorus. The carbon is of group 14 and which is having the relationship of the second element of the group 15. So let's see why they are diagonally related to one another. The first property we can understand its relationship. They both form the acidic oxides. Their oxides are acidic in nature. So they have the same nature. Both are very active non-metallic elements. Their nature, they are non-metals. They are very active and non-metals. They again show allotropy. They both show allotropy. They both form covalent compounds. Their hydrides, nitrides are also covalent in nature. So they are having the same covalent nature. Their oxyacids, if we talk about, or their salts we talk about, both are highly stable. So if we talk about all these properties, these are the similar relationship found in the carbon and phosphorus. The third relationship in the p block elements is nitrogen and sulfur. Nitrogen is of first element of the group 15, which has the relationship of the second element of a group 16, that is sulfur. And if we see their properties, both are again non-metals. They both are highly electronegative. This is one of the property again we can say prove their diagonal relationship. Their acidic oxides nature is same as they are of the acidic nature. The oxides both form the stable compounds with the oxyacids. They form the nitrates and sulfates. Understood, oxyacids like sulfuric acid, nitric acid. So the oxides are acidic in nature. They form the oxyacids. Both elements form the unstable covalent oxyhalides and halides. Either forming the oxyhalides and halides, they form the unstable. And when the nitrogen and sulfur react with the hydrogen, it forms the covalent hydride. So this is again the similarity. Non-metal, highly electronegative, oxides are acidic in nature, stable salts of the oxyacids, unstable or halides, oxyhalides, and covalent hydrides they produces. So this is all about part 2 p block elements. This is finish your unit 4. Thank you and take care.